Okay, so part of the deal here is not, part of it is we got to kind of translate what we see here. And remember, when I'm looking at this, I'm looking at the fraction bar is dividing this into two parts. The numerator, I'm going to treat separately than the denominator. I'll put them together at the end. Let's work on the numerator. When you see x to the minus 2, doesn't that mean draw a fraction bar? Little negative 2 is being a little brat. He doesn't like where his seat is, and he's being all pouty. That's why he's negative. I don't know if I told that story in here, or if that was just in earlier grades this year. When you have a negative exponent, he's not happy where he is. He wants to move to the other side of the fraction bar. If he's on the bottom, he wants to go to the top. And again, I'm talking about, I am actually in my brain covering up that stuff below that red bar. It doesn't exist to me right now. I'm talking about just looking at the top as if it were a separate problem, okay? So x to the minus 2, if I let him move to the other side of a fraction bar, he's going to be happy and he turns positive, okay? He's a spoiled little child. So what do I do with the top? I could fill in with a 1, because 1 times x to the minus 2, we could say that there was a 1 there all along that was invisible if we want to. Now, what about y to the minus 2? Is he happy where he is? No, because he has a negative exponent. He's a spoiled child also, and he does not like his seat. So he's in a classroom. He doesn't like where he's at. He'll be all happy if he gets his way. So we're going to move him to the bottom. I'm going to draw a fraction bar. Since there wasn't one there, we're going to say, okay, he's in the numerator of a fraction. Remember, the bottom doesn't exist right now. Everything below that red line doesn't exist. So I'm going to move him to the bottom. I'm going to make the exponent positive, and then if I moved everything out, I'm just going to fill in with a 1. That's the numerator. Am I finished with the numerator? No. Do you know why I know I'm not finished? Do I have a single fraction? Nope. I'm trying to create a single fraction in the numerator, and right now I am not even paying attention to the denominator. Could care less what it says down there, okay? So, how am I going to get a common denominator if I have 1 over x squared and 1 over y squared? What would a common denominator be? What's the smallest thing that both of those would divide into? Would it have to be x squared, y squared? Or another way of saying that, if they don't have anything in common, then you need to say, okay, the x squared needs to be multiplied by y squared over y squared. Just take, one thing you can always do is take the other denominator and multiply. Since I have x squared, the other denominator is y squared, I can multiply by y squared over y squared. Over here, I have a y squared. It doesn't have the x squared, so I could multiply by x squared over x squared. Remember, when I multiply by y squared over y squared, that's just 1 in a form that's helping me get somewhere, isn't it? I'm not changing the value. I'm just kind of giving it a little facelift because I need a common denominator. Okay, let's keep up with it. Wouldn't that be y squared over x squared y squared minus x squared over, it doesn't matter which one I write first because I'm multiplying, so I'm just going to write it as x squared y squared so it looks the same. Isn't that what I have now? And isn't that a common denominator? Okay, so I'm going to keep up. I'm still working on it. I'm going to put them together, and on the bottom it's going to be x squared y squared is my common denominator, and on the top, remember if you're subtracting fractions, you keep the denominator the same, the common denominator, and then you just subtract across the top. So now I've got a single fraction. Might not be pretty, but it's all one term, and that's what I need. Now let's work on the denominator, and we'll use a purple color just because it's dark. Now this one's not going to be so hard because I'm not adding or subtracting fractions. I don't need a common denominator if I'm not adding or subtracting fractions, do I? You with me, everybody? Dakota, you with me? Okay, you had your eyes closed. You look like you were sleeping. Okay, so these guys have negative exponents too, but they're not added or subtracted. So if I look at it, x to the minus 1 just means he wants to go to the bottom, and he'll have a positive 1 then, and I'll fill in with a 1 on the top. What makes this easier is they're smushed together. That means we're multiplying here, aren't we? So y to the minus 1, he was on top, but we're going to draw a fraction bar and move him to the bottom and make his exponent positive, and then fill in with a 1 on the top. I don't have to get a common denominator, do I? Isn't 1 over x to the 1 just 1 over x? And isn't 1 over y to the 1 just 1 over y? When you multiply those, don't you just get 1 on top and x times y on the bottom? Let me try to write that in there. That's what that simplifies to, and it's not like I don't have to do as much work on it. I'm just going to carry it along. It was multiplied, so I get to squish. I don't have to get a common denominator. Yay, right? Okay, so here's what I'm looking at right now. I'm not done with it, but here's where I am right now. I'm looking at this expression right here. Isn't that a fraction divided by a fraction? So I'm going to go, okay, to simplify this, I'm going to keep the numerator. It's a big fraction in of itself. I'm going to change the division here to what? Multiplication, and then I'm going to keep it changing. I'm going to flip the denominator. So instead of 1 over xy, I'll write xy over 1. We're almost done here. Yeah, if I take 1x, if I could cancel out this x with this x squared, that would leave an x down here. I could say y goes into y one time, and then y goes into y squared y times. So yeah, I've got an xy on the bottom. And honestly, is there anything else that's going to cancel out here? I could factor that. I've got y squared minus x squared on the top, and I've got xy times 1 on the bottom. I could factor the top, but it's not going to help me get anywhere. So I have a feeling, let me check and peek. Yeah, 57. Yeah, they just leave it like this in the answer key. They don't do anything else with it. If you could factor it, it wouldn't be wrong. It just might not be necessary. Okay, so 49, here we go. I need to get a single fraction on the top and a single fraction on the bottom, and then I can deal with it like a complex fraction. So on the top, I'll do that in red here. All these things, couldn't I put all this x in the 3 over 1? Because they're missing a denominator. So if I want to get a common denominator, isn't it going to be x? So that means I need to take x over 1 and multiply it by x over x. I need to take the plus 3 over 1, and I need to multiply it by x over x. And then I've got plus 2 over x. It has the common denominator. All of that's just the numerator. So let's just keep working on the numerator. That would be x squared over x plus 3x over x plus 2 over x. And they all have a common denominator now, and when I add fractions with common denominators, don't I just keep the denominator? So if I want to rewrite it, I keep the common denominator of x, and I just add across the top, so that becomes x squared plus 3x plus 2. Man, I wish I'd left more room for my denominator. On my denominator, 1 minus 4x squared, won't it have a common, remember if I put the 1 over 1, my common denominator would be x squared. I already have it on the second fraction. For the first fraction, let me write x squared over x squared. That becomes x squared over x squared minus 4 over x squared. And since it's got the common denominator, I can just write the common denominator down. And then just subtract across the top. That becomes x squared minus 4. And now I'm like, yay, I have a single fraction on the top and a single fraction on the bottom. At this point, this problem looks like what we started with. I mean, it's the same thing as what we started with in this section. It's just that it looks weird because it's a stacked fraction here. So it's x squared plus 3x plus 2 over x. I keep the numerator. I change the division to multiplication, and I'm going to flip the denominator. So that means the x squared would go on top. Keep it, change it, flip it, right? That's what I'm doing right now. And now, to finish this out, you'd factor the parts because you want stuff to cancel out. We can see some stuff's going to happen with the x already. We can see that x goes into x one time, x goes into x squared x times. But for anything else to cancel, I got to factor it. So let's see. Oops, I put two equal signs. I'll make one big one. On that first one, if you're trying to multiply to get 2 and add to get 3 for this first fraction right here, wouldn't that be x plus 1 times x plus 2? 1 times 2 is 2, and 1 plus 2 is 3. And it's over a 1 because I already canceled the x's out. On the second fraction, I can write my x down on top. And isn't this x squared minus 4 the difference of two squareds? It's x squared minus 2 squared, right? So this would be x minus 2, x plus 2, and I'm going to have to run down here with it because I'm just totally out of room. And then if you look, stuff starts canceling out. The x plus 2, that looks awful here, cancels out with that x plus 2. And I end up with x plus 1 times x. I'm going to write the x first. I always like doing that, and usually that's what books will do too. They'll put the x out front. It's multiplication, so it doesn't matter. I can switch the order. What do I have left on the bottom? Yeah, x minus 2. So that one, that's how you'd finish that one out.